In this section, we're talking about our special right triangles. These are still right triangles. The Pythagorean theorem still works on this. You can go a squared plus b squared equals c squared. But typically, when you're using the Pythagorean theorem, you already know two sides to help you find a missing third side. What makes these right triangles, the special right triangles, is that we only have one side. So actually, we cannot use the Pythagorean theorem because we don't have enough information to plug it into that equation. So we have some additional formulas here for these two triangles. We call this the 45, 45, 90. And down there, we'll get to the 30, 60, 90. And they each have special formulas to help you find missing sides when you only have one side to begin with. The 45, 45, 90 is essentially an isosceles triangle, right? An isosceles triangle has two sides that are the same size, which means that the x's that you see here are representing the same size, the same length, the same number. The hypotenuse is always bigger than the leg. And specifically, it's not just randomly bigger, it is bigger with a multiplier of root 2. So what makes these triangles special is that we have the formulas that help us find missing sides with knowing just one to begin with. But also we can find the length precisely. So no decimals are allowed in this section. We will do everything with simplified radical form. So what you're seeing here, this is saying take the leg length that you find on x and multiply it by a root 2. That's what you're seeing written out in words here. The hypotenuse is bigger. How much bigger? It is root 2 times as long as each leg, meaning you take the leg size, you multiply it by root 2, and that'll give you the hypotenuse. So that's the formula you see right here. The length of the hypotenuse equals the length of the leg times root 2. So this is what you need to memorize. And we'll be seeing a lot of examples of this today. So just to reiterate, no decimals are allowed in this section. Our special right triangles allow us to find answers precisely. Before we jump into the examples, take a look at this. This is set up as an extended ratio. We talked about ratios in the previous chapter. You see the colon sign right there. The 1 to 1 is talking about these two sides, which are the same size. So because they're the same size, they are the same in their ratios, 1 to 1. And then the root 2 is talking about how many times bigger the hypotenuse is. So this is one of your legs, this is one of your legs, and this is the hypotenuse in that extended ratio. So for example, let's say this leg was a length of 2. Well then, this leg would also be a length of 2, which means this would be 2 times root 2. Here's another example. Let's say this leg was a length of 5. Then that means this leg would also be 5, which means this hypotenuse would be 5 times root 2. So that's the formula that you see there. We're taking the leg size of 5 and multiplying it by root 2, and that's the length of the hypotenuse. Let's say this leg were 10. So if this is a 10, this leg would be a 10, and this hypotenuse would be 10 times root 2. So that's a way of viewing it. We're going to primarily be focusing on setting up the equation and plugging in the values we have and working our algebra to find the missing sides. But that's a way of representing how those sides relate to each other in their lengths. Let's try example 1, which is really 4 examples here. So what we have is these tick marks telling us we have an isosceles triangle, which means this angle must be 45 degrees and this angle must also be 45 degrees. So it really is a special right triangle. It's a 45, 45, 90, and so we can use that formula. We start off by identifying our sides. Next to the right angle are the legs. So we know this is a leg, we know this is a leg, and opposite that right angle is the longest side, and we call that the hypotenuse. Okay? So we don't find the length of all of the missing sides, and they only gave us this leg of 12 centimeters. Well, we know this leg must also be 12 centimeters. And that means the hypotenuse is 12 root 2 centimeters. we're using the pattern that we saw here. But how do we know that? Well, let's set up our formula. The hypotenuse equals leg times root 2. Again, that's what you have to memorize. We're now going to plug in the value of the leg, which is the 12 centimeters, so my hypotenuse equals, so here's the substitution, plugging in the 12, and that's it. We don't have any algebra work to do here because our hypotenuse is the variable. The variable is already by itself, so we don't have to do any algebra work to get it by itself. It's already all set. Here in part B, there's our right angle, so this is a leg, this is a leg. Right, here's your hypotenuse opposite the right angle. So the formula is hypotenuse equals leg times root 2. So this time the given information is the hypotenuse. This will go here on the left-hand side. So there's my 6 root 2 equals, and you could pick a variable like x or y if you want. Right now I'll just call it leg, and that's my variable. So leg is the variable. We want to get the leg by itself. It's currently being multiplied by the radical 2, so we have to undo that with division. We're going to divide both sides by root 2. So on the right-hand side, root 2 divided by root 2 cancels out. And on the left-hand side, you happen to have a root 2 divided by root 2 that also cancels out. That means your unknown leg is 6. So this leg is 6 and this leg is 6 because, again, it's an isosceles triangle. Here's part C. This is where it gets a little harder. These last two are harder here because the information doesn't contain a radical. Again, it's a 45, 45, 90 because we know it's an isosceles triangle. So this is a leg, and we have our hypotenuse provided to us. So here's our formula. Hypotenuse equals leg times root 2. Plug in the 10 for the hypotenuse. And again, for the leg, you could plug in an x or a y, whatever variable you might want. I'm just calling it leg times root 2. And we're going to get the leg by itself by dividing away that root 2. And you can see the root 2 does cancel out on the right, of course. The variable is now by itself. Unfortunately, we cannot keep our answer with a radical in the denominator. We have to rationalize the denominator. So we're going to multiply top and bottom by a very special multiplier using that root 2 on both top and bottom. Now top times top gives us 10 times root 2. Bottom times bottom is a root 4. Square root of 4 is 2. And then we can simplify the fraction itself. You see that 10 divided by 2 right there? So that gives us 5 roots of 2. So that is the leg size. So this is 5 roots of 2, and this leg is also 5 roots of 2. Those are both the same size. That's the skill we were practicing at the beginning of this chapter when we were talking about rationalizing the denominator. So if you are looking at this problem right here, that's the hardest version of these three, where we have to rationalize the denominator. So I want you to try that. If you can, pause the video, try part D right here, and then turn it back on when you're all set, and we'll work it through together. Here we are back again. We're working it through, labeling all of the sides. Here's the formula. Hypotenuse equals leg times root 2. My hypotenuse is 12. And again, if you want to take that leg and call it a variable like x, for example, you can do that. Just label it on the triangle so we know what x is identifying. Let's solve for x, which represents the missing leg. X is being multiplied by the root 2, so we're going to divide both sides by that root 2. Cancels out on the right side, but it does not cancel out on the left-hand side. And we do have the variable by itself. So x equals 12 divided by root 2. But we have to rationalize the denominator. Multiply top and bottom by root 2. And that will give us 12 times root 2 all over. Root 2 times root 2 is a root 4, and the square root of 4 is integer 2. And now we can reduce our integers here, and this leg length is 6 root 2. So x equals 6 root 2 on both of those legs. So that's the first of the two special right triangles we're talking about today. We'll have some more examples of the 45, 45, 90 in a little bit, but first let's talk about the 30, 60, 90 triangle. You see that in the box right underneath. So there is your 30, 60, 90 triangle. There it is. And because we have two different angles, then that means we'll have legs that are different sizes as well. And that means we have two different formulas for the two different legs. So we have to keep track of which leg we're talking about. We have a shorter leg, and then we have a longer leg. So we need to talk about them as short legs and long legs. So we'll talk about this as our short leg, and we'll abbreviate that as the SL. Now, how do we know that's the SL? It looks like the shortest leg, but in case you're not sure, find the smallest angle. See that 30 degrees is smaller than 60 and 90. We know opposite the smallest angle is the smallest side. So that's how you know that will be the shortest leg. In the same way, you know the 90-degree angle is your biggest angle. So opposite that is the largest side. And of course, we know that's the hypotenuse. But that's the biggest side because it's opposite the biggest angle. The medium-sized angle is opposite the medium length side, but as it's a leg, we're going to call that the long leg. And we'll abbreviate it this way, SL for short leg and LL for long leg. So again, we have a short leg that is represented by X, and the hypotenuse is represented as 2 times X. What that means is the hypotenuse is bigger, 2 times bigger than whatever the short leg is. So if the short leg is 10, the hypotenuse is 2 times bigger than 10. So that's what we're describing here. The hypotenuse is twice as long as the shorter leg. And here's that formula. So hypotenuse equals 2 times the shorter leg. Now the longer leg is also bigger than the shorter leg, but it's not a convenient, like just 2 times bigger or 3 times bigger. No, it's actually bigger by a multiplier of root 3. So it is bigger, but it's not as big as the hypotenuse. It's not 2 times bigger, it's just root 3 times bigger. So it says the longer leg is root 3 times as long as the shorter leg, and that's your formula down here. Long leg equals short leg times root 3. And again, these are the formulas that you need to memorize. And again, no decimal answers here either. Now this is again a way of representing the extended ratio of those 3 sides. So where you see the 1, that's the smallest side, that's your short leg. Where you see the root 3, that's your long leg, and we see the 2, that's your hypotenuse. So what we're saying is if the shortest leg is 1, well, the hypotenuse is 2 times bigger than that. So 1 times 2 is 2. Let's imagine that the shortest leg was 10. All right? Well, then the hypotenuse would be 2 times bigger than that. So that would be a 20. The longer leg is also bigger, but it's bigger by multiplying a root 3. So this looks a little bit weird, but it's going to be 10 times root 3. So there's your extended ratio using a short leg of 10. Medium or long leg is 10 root 3, and then the largest side is double that, 20. We're going to see that in the formulas here. So let's just go right to our examples. Example number 2, we have all 3 of these triangles here. The first thing you have to do is identify your smallest angle, and opposite that is your smallest leg. So identify that as your short leg. That means the leg here on the bottom is your longer leg, and then across from your right angle is your hypotenuse. All right, so here's the first of the 2 formulas. Hypotenuse equals 2 times the short leg. We're using SL for short leg. And the short leg is 2. Let's plug in the number 2 right there. So hypotenuse equals 2 times 2. Of course, that'll be a 4. So now we know the hypotenuse is a length of 4. It's always double the size of the short leg. Here's the second formula. The long leg equals the short leg times root 3. So let's plug in our short leg of 2 right here as well. So the long leg equals 2 times root 3. There's our variable. It's already by itself, so we don't have to do any algebra work. That's our long leg, 2 roots of 3. Let's see that again. Here's part B. Again, find your smallest angle. It's not the 60, it's the 30, right? It's not printed on the page. All the angles add up to 180, so 180 minus the 90 minus the 60 gives you 30. So there's your smallest angle. Opposite the smallest angle is your shortest leg. On the other side of the right angle, there's your long leg. And then opposite the right angle, there is your hypotenuse. So the first formula here is hypotenuse equals 2 times the short leg. Well, I don't have a number for the short leg, so I can't plug that in. And I don't have a number for the hypotenuse, so I can't plug anything in here. I don't have this information yet, so we'll come back to that formula in a moment, but that's not the one we can start with. We'll start off with the other one. Long leg equals short leg times root 3, because the only information they gave us belongs to the long leg. That's where we have to start, with the formula involving the long leg. So we'll put the 5 root 3 here in place of the long leg. 5 root 3 equals the short leg times root 3. We're going to solve for the short leg. That's our variable. Since it's being multiplied by that root 3, we're undoing that with division, and we're dividing both sides by root 3, which cancels out on both sides. So the short leg is exactly 5. Put that back on the picture. There's our diagram with the short leg of 5. Now we take that information that we just found back to the first formula to finish it up. The hypotenuse is 2 times the short leg. The short leg is 5. So 2 times 5 gives us a hypotenuse of 10. And we have all the missing sides. And then here's the last in the series. And this is the one that's the hardest of them all in terms of the most algebra steps. And that's because this long leg doesn't have a radical. Let's see what's happening here. There's our 90-degree angle. There's our 60. This must be our 30-degree angle. So opposite the 30-degree angle is the shortest side. That's your short leg. Opposite the right angle is your hypotenuse. Right, so if this is the short leg on the height, then the base is the long leg. So we know the long leg. That means we'll start with the formula with the long leg. So long leg equals short leg times root 3. We're going to plug in the 10 for the long leg here on the left side of that equation. So 10 equals the short leg times root 3. We have to solve for the short leg. That's our variable. So to get it by itself, we have to undo this multiplication. We're going to divide both sides by root 3. And on the right side, the root 3's cancel out. And our variable's by itself now. So the short leg is 10 over root 3. Unfortunately, we can't leave our answer this way. We cannot have a radical in the bottom. We have to rationalize the denominator. So let's multiply top and bottom by root 3. That means we have 10 times root 3 on the top. And on the bottom, we have root 3 times root 3, which is a root 9. And that's a perfect square. The square root of 9 is 3. So that doesn't look like a very friendly number. 10 root 3 all divided by 3. It doesn't simplify. That's what it is. But that is the length of the short leg. 10 root 3 over 3. Now we can take that to find the hypotenuse. Hypotenuse equals 2 times the short leg. And now that we know the short leg, we'll plug in this fraction, 10 root 3 over 3. So I usually pause at this point and just kind of ask, what exactly are we multiplying by 2? Think about this for a moment. Are we multiplying the 10 by 2? Are we multiplying the root 3 by 2 to make that a root 6? Are we multiplying the bottom denominator of 3 by 2 to make that a 6? What exactly is being multiplied by 2? Remember that 2 is 2 over 1, and when you multiply fractions, you multiply straight across. So in other words, the denominator is not doubling. That stays a 3 because it's just 1 times 3. And on the top, this is not distribution. We're just multiplying integers with other integers. we don't double the radical here. So it's 2 times 10 is 20. You still have the root 3 being multiplied to that. And on the bottom you have 1 times 3. So again, it's not a great looking fraction, but it is precise. Right? These special right triangles give you answers that are exact, and that's the exact answer. So you've seen all of the new information, but we have a couple more examples that we need to go through to help you with the formatting of certain questions. Here, we just had one triangle at a time. So if you'll turn the page with me, you'll see that this is another way to set up the information in tables. And I want to talk you through how to solve this because it might not be clear exactly what you're supposed to focus on in any of these. All right, first of all, we'll do the 45, 45, 90, and then we'll go to the 30, 60, 90. We want to complete the tables, but we usually have to show some work, and that's what the space down here is all for. You want to think of this row, so this is labeled as X, as referring to the X that you see in the picture, so those are your legs. And then here you have the Y, and you can see the Y in the picture, that's on the hypotenuse. And each column that you are looking at represents a unique triangle. So really think of it as multiple problems that involve the same special right triangle. So here I'm going to call this part A, if you will, and I'll call this part B. They're really two different triangles, and so I'm going to set up and solve part A. What you really do is just draw the triangle all over again. This is the Y, this is the right angle, that's the X, that's the X. And what you're doing is you're really just focusing on that column of the table that is referring to what I labeled as A. So pretend the B is not there. I'm going to cover it up. Right? That triangle information does not apply. So what they're saying is they're giving us some information and we have to find the other information. They're giving us the leg, which is 18. Right? So okay, this is 18. This is 18, and our job is to find Y, which is the hypotenuse. All right, so the formula is hypotenuse equals leg times root 2, and the hypotenuse is the letter Y. The leg is the 18 times the root 2, and there it is. So the variable's by itself. We have no more algebra to do. This is the 18 root 2 that goes in that column. All right, and then we're going to take a look at the next diagram, which I'm calling B. And I'll slide this down in a moment, but it's the exact same triangle, so draw it all over again. There's the Y on the hypotenuse, there's the X, and what's different here now is you are looking at only the right-hand column and ignoring the rest, so it's like this, meaning we have to find the missing leg. They're only giving us the hypotenuse. So the hypotenuse now in this triangle is 3 root 6. And what we don't know are the legs. All right, so here's the formula again. Hypotenuse equals leg times root 2. You have to memorize that. Plug in your hypotenuse, which is the given information from the table. The leg is represented by the variable x, and our job is to solve for x. So we're going to divide both sides by root 2. And now our variable is by itself. Here we're going to simplify this. There's your integer of 3. There's your root 6 divided by root 2, which is a root 3. That's your leg length, 3 root 3. And we put that information in the table, 3 root 3. So it's really a way of just condensing two different triangles. Because both triangles are 45, 45, 90s, we can share the same diagram. We're just kind of pull the information apart one at a time. All right, so now for the 30, 60, 90, we have 3 more triangles. So I'll call this part C, I'll call this part D, I'll call this part E, and that means we have 3 separate triangles for the 30, 60, 90. We have the A, the B, and the C rows, which are representing the different sides. So let's see what we have here. Here's the smallest angle. Opposite that is the short leg. So in other words, letter A is representing the short leg. Opposite the right angle is your hypotenuse. So they're using letter C to represent the hypotenuse. So letter B is representing the long leg. So again, we just look at one column at a time. And here for column C, they're giving us information about the short leg, and we have to figure out what is the long leg and what is the hypotenuse. So I'm going to redraw this picture, put the number on it, and we're going to solve that. There's the ABC. They're telling us in this column that 4 is the length of the short leg at letter A. I should probably label on this my short leg, my long leg, and my hypotenuse to help keep track of what we have. So here are the formulas. Hypotenuse equals 2 times the short leg. My hypotenuse is letter C, and the short leg is a length of 4, so that means C is 8. So we'll put that information here in the table. To find the long leg, we have long leg equals short leg times root 3. The long leg is letter B. The short leg is 4. There's our variables by itself, so we don't have any more algebra work to do. There's 4 times root 3, and that goes here in that column of the table. All right, so now we'll do this column called D. I'll draw that triangle again. I'm off screen at the moment, but I'll come back and update what you're seeing here. All right, so I just redrew the triangle with the A, the B, and the C, the short leg, the long leg, and the hypotenuse. And there's your 30-degree angle. Right? And so in this middle column, what they're giving us now is only the long leg. We have to work backwards to find the other two sides. So the long leg is 4, so let's put 4 here at the long leg. And we have to now solve. So here are the two formulas. We have hypotenuse equals 2 times the short leg, which we can't solve yet because we don't have any information on the hypotenuse or the short leg. And then long leg equals short leg times root 3. This is where we start because we have information on the long leg. So 4 equals, the short leg is represented by letter A times root 3. So we need to divide both sides by root 3. And our variable is now by itself. A equals 4 divided by root 3. But we got to rationalize the denominator. And we get 4 root 3 over. It's root 3 times root 3 is root 9, and square root of 9 is 3. That is letter A. So we can put that information in our table. So in this middle column, A is now 4 root 3 over 3. We still have to find the hypotenuse. So we take that information that we just found. We can go back here to the previous equation. And so we have the hypotenuse, which is letter C, equals 2 times the short leg. And that short leg is 4 root 3 over 3. Again, we're only doubling that 4. So the length of the hypotenuse is 8 root 3 over 3. Now you might be able to pick up on some patterns here. There are patterns in the numbers, right? For example, we know the short leg and the hypotenuse have this kind of pattern where you can see this doubling effect go on. So if you can pick up on the patterns, you can use that to your advantage in filling out the table. So for example, this went from 4 to 8. We doubled it. In the middle column, we went from a 4 to an 8 as well because we're doubling that integer. So what if we went backwards? If our hypotenuse was 4, then the short leg should be half the size, right? Let's double check. Let's verify that. So I'll use this space right here to do this last part, E. All right, so here's the triangle again. There's the labeling of all the sides, the A, the B, the C. There's the short leg, long leg, and hypotenuse. And in this rightmost column, we're starting off with hypotenuse of 4. So let's try out the formula. Hypotenuse equals 2 times the short leg. So we have the hypotenuse, which is 4. The short leg is the letter A. So let's solve for A. Divide both sides by 2. And we get A equals 2. Yeah, so that worked, right? That was the pattern that we were recognizing. So now can we figure out the pattern to go from the short leg to the long leg? We know the long leg is longer. How much longer? It's root 3 times longer than the short leg. So if my short leg is 2, then this should be root 3 times longer, 2 root 3. Let's see if that works here. Here's the formula. Long leg equals short leg times root 3. The long leg is what we're trying to find. That's the letter B. The short leg, we now know, is 2. I didn't put that on my picture, but from the previous calculation, we know A is equal to 2. So we're going to take that 2, plug it in here for the short leg. And look at that. 2 times root 3 is, in fact, 2 times root 3. So what we're saying is if you can start picking up on the patterns here, that can make things go faster because you won't have to do the calculations every time if you can figure out what will be 2 times bigger or half the size or root 3 times the size in each of these special right triangles.